we're going to do some more work with constant rate of proportionality and looking at ratios on graphs and equations. Love this topic. It's just so interesting to me. I love being able to see our rate and proportion in different formats, in different forms. So let's jump in. The graph shows the relationship between the number of people in a group and the total cost of admissions to tickets for the circus. And we want to know, what is the constant rate of proportionality? So Math Marvel, what are they asking us for? They want us to find the K in y equals kx. Now we know this is proportional. We've gone through this before. This is linear. We also know that it starts at the origin 0, 0, and it is increasing. I see that as the number of people increases, so does the number of dollars. So how do we check for K? We're going to just pick some points on our graph. I'm going to randomly just pick 2 points in the graph just to check for K. And the first ordered pair is 3 and 45. So remember, I have to start here with this number is X, run and then rise. And our second point is 6 and 90. So here are ordered pairs, and we're going to test. Point 3 and 45. I'm going to write our equation, y equals kx, and I'm going to substitute. 45 is equal to 3 times k. Now remember, when you're looking at these, they're always in alphabetical order, x and y. So don't screw those up. A lot of kids just get them backwards. Now that I have this part, I'm going to solve for k. I'm going to divide both sides by 3. And k is equal to 15 for the first point. Let's go and try and the other points. And let's see, that would be point 6 and 90. I'm going to do the exact same thing. Y equals kx. 90 is equal to 6 times k. And I'm going to divide both sides by 6. And of course, I like doing this in my head, but just so you can see where I'm getting the numbers for, 6 goes into 9 once. 6 goes into 35 times, so 15. And as you can see on these points, K is always going to be 15. That is, I picked 2 points. There's something else I want you to see here. So first, let me just write this down. K equals 15. So if y equals kx, and we know that k equals 15, our equation is y equals 15x. Other thing I want you to look at here, you can look for the unit rate. And the unit rate is when x equals 1. When x is equal to 1, what is y? What do you notice, Math Marvel? When x equals 1, y equals 15. So that is our simplest one. You can also find k by just identifying your unit rate. So, but I'm going to hit pause here so you can jot this down into your notes. And we're going to do one more together, just like this. What equation represents the graph? So that's what we want to know. And for that, we need the constant rate of proportionality. So we're going to do the same thing, just like last time. We see this proportional. It's it goes through the origin, it's linear, it increases. So I'm going to use these 2 points, 220. And I'm going to use 660. So y equals kx. So let's use the ordered pair is 220. So 20 is equal to 2 times k. K is equal to 10. We'll do the same thing with the other one. We're going to use 6 and 60. So 60 is equal to 6 times k. Divide both by 6. 10 is equal to k. So we know what k is. K k is equal to 10. We know our format, y equals kx. Therefore, y is equal to 10x. There you go. Now, if you want to use the second way and you had to look for your unit rate, look for when x equals 1. In this case, it will be right here. This is where x equals 1, and what point is that? That is at 110. So that would have been finding just our unit rate. But there you go, Math Marbles. I know it seems easy, it seems like magic, but it is not. It's using our equation to just calculate for k and finding that constant rate of proportionality. We are finding the relationship between x and y. And y is always 10 times bigger than x. That's the relationship you see here. Y is 10 times bigger than x. That's why it works. Hit pause and we'll jot this down into your notes. And I hope you continue using your equation or using unit rate in order to find k, and that using that to make your equation. Take care, Math Marbles.